Hello everybody, how's it going? Good morning if it's morning for you. I don't think it is. It's fine, not morning for anyone. It depends when you watch this. If you're not live, then it could be morning. Otherwise, I just say good morning out of instinct all the time. Also, laughing at myself because I did set up this live stream for 4 p.m. And I thought that maybe that was a bit late in the day. But it does change the it does mean it dodges most of the tutorials and labs. But also I got these slides finished about half an hour ago, so I'm glad it was later in the day. Max asked if I've moved. I haven't actually moved. I just changed my camera angle. So I have a weird setup where I've got my laptop facing the window, which is the window to my apartment there, and like 90 degrees across is where my second monitor is, because it's all just kind of spread out over the table, because I've got a whole bunch of stuff here for my miniature painting on this side, so I don't really have space for a normal 2-monitor setup. I've got all these pots of paint here instead, all behind where you are in the camera. So what I did was I put the camera in between the two computers, so there's less of me kind of like looking all the way away from you now. Like if I'm looking at my computer, I'm looking at this angle. If I'm looking at chat, I'm looking at that angle. So I'm nearly kind of facing you most of the time. So today we are going to have a bit of a chat about assignment 2. I'm trying not to make this a full-on lecture, because full-on lectures, as you know from listening to them as well, a little bit tiring. Anyway, so I don't necessarily want to do 3 full-on lectures in a week. However, I am still going to tell you some useful information about the assignment today, but also there's a bit of answering questions and stuff like that as well. So I do have some slides, but as you'll see, there aren't nearly as many slides as I would have in a normal lecture. I think that we'll be able to get through the slides in about 45 minutes, and then we'll have an hour and a bit for me to answer questions and stuff. But I will also poke into the code itself and show you some things. So, castle defense. We called it castle defense because if you look at the letters in castle, it actually nearly spells out CSE. So castle was CSE, so we ended up calling it castle defense because of that. This term, I've used this theme before. It's not the same backend for the assignment, but the same theme before, the idea that you are at a tower defense. So if you haven't seen tower defense games before, they're games a bit like these that have these enemies that are just going to walk towards you along this path. And the way that you play the game is to place towers. So Plants vs Zombies, you grow plants. Tower defense, desktop tower defense is this one, is like the idea that you're actually drawing pictures of them, and then these towers will automatically attack enemies as they move through, and you've got to stop the enemies from reaching some end somewhere. This was an idea after several iterations of bouncing around of ideas about what would be an interesting assignment for people to do using linked lists, and we thought this would be kind of interesting because you can have the idea that you have a chain of locations that go between one place and another, and then we thought, oh, it'd be even cooler because the way that you'd often do things with tower defense is you place towers in the way so that people have to walk around a longer path, and we could literally make the path longer by allowing people to insert towers in between nodes in a linked list. And I was like, beautiful, perfect, that'll teach people about using linked lists and about insertion and stuff, and then maybe those towers can be removed and stuff. I don't think we're actually doing that much with removal in the assignment. I don't remember because there's lots of stages in the assignment. But anyway, so this is the theme. The theme is, and if you've read it, if you read it a lot this time, Tom's reminding me I'm mispronouncing. It's Catstill defense. That this time we've changed the theme so that it's actually Chicken's castle, and she's under attack by Frankie and the other foxes. So So we're getting oh, Tom's reminding me, yeah, enemies get removed, so there is definitely removal from linked lists. I mean, we never really would have gotten to this point in an assignment without having insertion and removal to get you to practice everything. But you know, it's in stages like any assignment. I'll talk about that in a second. So this is the theme, is that there are locations, and in the examples we often use locations that are like UNSW locations, which is, I guess, a little bit ironic now to use UNSW locations because all of them are openly hostile to humans. I don't know if there's COVID on campus at UNSW at the moment. It's highly unlikely that there is, but there's still no way that we're going to be like spending time there anyway. So you know, that's the way it is. Then what we have is those locations, and we have enemies that will just move along the set path along those locations, and then we might have towers, and towers would do damage to the enemies. So it's this whole thing, and we'll slowly build up the capability to do that. And if you're not interested in the theming, you're not interested in the kind of idea that this is a game and stuff, you can think of it as a linked list as the primary data structure that we're using, but attached to each node in the list you can have another linked list, which are entities that will actually move along the linked list, and there's ways of figuring out how to get them moving and things like that, depending on how deep you go into the assignment as well. We also, because we've taught you a bit about strings and things like that, if you go much deeper into the assignment, into stage 4 or 5, we have some advanced string content there. There's some not as advanced string content in the early parts of the assignment as well. So this is leveraging basically everything we've learned in the second half of the assignment. You could think of this as also leveraging a lot of what we learned in the first half of the assignment, because your if statements and while loops are going to be indispensable for this. You won't be able to do this assignment without doing some if statements and while loops. I think the only thing that you're not expressly going to be working with is arrays, although if you think about it carefully, every string that you work with is an array as well. So one could consider this assignment, the first assignment, to be the assignment for the first half of the course, and then this second assignment is the entire course being practiced in the assignment. Okay, so slide about tower defense games, and I've already explained this. So yeah, the way that these work is that the enemies are going to move along the path, and if we were playing the game, we'd be trying to build the towers in the right way to destroy all the enemies before they can make it to the other end. So this is to stop all the foxes from getting to Chicken and taking over Chicken's castle. Having said that, what we're doing is we're building the back end, the engine. So it's nearly like the calculation engine that decides how the enemies move, how much damage they take, how much space they cover when they move, and things like that. So we're going to be putting these locations in as these step-by-step. We're not necessarily doing the same thing as these games. We're not having real-time, like frame-by-frame movement of things. We're going to do it in a more simple way than that. That's actually, like, that's a non-trivial thing to do in C. So we're going to have basically the idea that if you put in a command saying the enemies advance, that's nearly like a time step going forwards. It's not exactly, because we would also do things like applying damage, and so we have the back end for a game where we could say that every time every time step in the game you would move the enemies, then you would apply damage, and then you would see who's won and that kind of thing. So it's not that much different to freefall, so you should be at least a little bit used to this idea that, like, when we ask you to build something, it's not from the perspective of the human playing the game, it's from the perspective of us making the computer program so that someone else would be able to play it. If you want more detail than I'm saying now, obviously, the assignment spec is on the course website. I have it here ready to go into here and have a look at these things if we want to. I'm probably going to stick to my slides a little bit because anything here is stuff that you can read. However, we'll bounce back and forth if people need it. So Duke's got some questions there. and Dylan as well, talking about the struct inside the struct, realm and location, and things like that. Yeah, we'll have a look at that in a second. So, some of the basics to get castle defense going. So there is a reference solution to castle defense that you can try, and then you can see how the interactive version of the assignment works. So I've got this here. So I can go 1511 castle defense, and this is us as the engineer, and as Tom says, bonus marks for finding bugs in it. So if anyone finds any issues with the reference solution, or finds any way that the reference solution and the spec don't agree with each other, we're more than happy to hear about that, because it means that we need to clarify something. Something that you should learn, and you probably already know, because pretty much no one has ever used a piece of software that's actually perfect, because I don't think that humans have ever written a piece of software that was actually perfect. We go to great depths to write software for things that are the most important things we can think of, like space shuttles, where we really want this software to never fail under any circumstances. And yeah, we see how that's gone in the past. You know, like there was an issue with one of the Challenger missions. This isn't actually one of the, I don't think software was responsible for any of the Challenger missions actually killing people, because I think 2 of the Challenger shuttle missions blew up, which is a very, very sad thing. But even at that level of making code, I remember hearing about one of the Challenger missions where the astronauts were all in the shuttle there waiting to take off, and then the computers in the space shuttle could not agree on whether they're allowed to take off as well. Oh, right. Carol's video talks about the Challenger missions. I should actually watch it. I mean, like, I've been I've publicized it in the course, but I haven't actually taken the time to go and watch it. Oh, you're talking about the perfection of code and how hard it is to actually achieve. Yeah, so they did something once where they had, I think the Challenger, the space shuttle, was so safe that they had 6 separate computational systems. So they were completely separate computational systems running on their separate hardware. And if all 6 of them agreed, then the calculation would go through. But the 6 of them could not come to a consensus that the shuttle was safe to take off. And so it sat there on the launch pad for 48 hours before they could take off. So I think they had to get to the point where they had to take the astronauts back off the shuttle and give them a bite to eat and stuff like that, and let them have a sleep before they were actually ready to take off. And so you get these kinds of things where even at our most us attempting to do the best that we can, and the most careful we are with things, are still not going to be perfect. So don't expect us here in COMP1511 to always write perfect code either, and don't be too worried if your code's not perfect. Code is often in a constant state of iterating to get better and better. Liang, just turn off the warnings and take off. Yeah. I'm not going to say any more about that. So may I refer you back to the Ariane 5 rocket again, in terms of like what happens if you just take off. Anyway, so if we want to look at using castle defense here, I can press the question mark here. The question mark is the one command that you're always going to want to know about. Oh wait, I have to set up locations first. Oops. Oh no. Let's see if that question mark turns into one of... That question mark is going to end up turning into one of the locations. Sorry, I thought we were already at the next step. So quad, K17, that should do. 5 locations. Okay, now we can enter the question mark. Sorry, I jumped ahead. Question mark says, okay, what are the things that we can do? So for the moment, we could print the current layout, which I think is what we want to do to see where we are. And I've accidentally created a location called question mark, because I jumped the gun and tried to insert one of the commands before I'd actually done the setup. So each of these is a location. Every time we run this, we will always have a castle and a lair. The lair is where the foxes come from, and the castle is where Chicken hangs out. And we want Chicken's castle to survive the onslaught of Frankie and the foxes. I like the storyline that we've got going here. It's a very deep storyline. And so what we can do here is we can add things like towers, and the towers are going to do damage to the enemies as they go past. We can add enemies as well. So let's add a tower, and you'll see that the tower actually doesn't get built on a location. It actually puts itself in between locations. So T for tower, after location. So if we're going top down, we're saying after location. So let's say after quad. The name of the tower. So near the quad in that area, there's the what would it be called? I'm gonna call it the cyber ball, because it's like, you know, that the metal sculpture of a sphere on the mechanical engineering lawn. Yeah, that's what I'm referring to when I say the cyber ball. And it has a certain amount of power and a certain number of uses. So the power is how much damage it does to enemies as they go past, and the uses is how many times it can do that. So I'm just going to put some numbers in, like 5 and 5 there. And let's print out now and see what we can see. Okay, so after the quad, here we have the cyber ball. Power 5, uses 5, and that there is for later on. In later stages, we can actually change the tower into different types, but we're not too worried about that yet. So basically, this is a tower, and you can see how, if this is a linked list, I've just inserted a new element into this linked list. We can then add things like enemies as well, so enemies have the same kind of things. Enemy after location. So if I do this enemy after K17, it should appear at the lair. Oh, did enemies have an after location or an at location? I think it's an at location, right? So if I go lair, then the enemies will appear at the lair. The cyberball lawn, yeah. So enemy at the lair. And I will say this enemy is Frankie, and Frankie has 10 hit points. So we have a look at this, and Frankie's now listed underneath the lair here. And if I wanted to, then I can do stuff like advance the game state. Oops, which was advanced game state is N. What did I type in? A. Okay. N advances the game state. The enemies advance, 0 made it past the castle. If we look at this, Frankie has now moved from the lair to K17. And so the way that if we were running this game in the background, what we would be doing was we'd be saying advance game state, then apply damage, then advance game state, and then apply damage. Because each time we try to apply damage, towers attack the enemies, no enemies were hit. That's because the cyber ball exists at this location and Frankie's not yet at that location. But if I was to then press N, advance the enemies further, have a look at where we are. Now the cyber ball is in the same location as Frankie. So Frankie is just this line below the cyber ball here. Oh, I don't want N, I want D for apply damage. Towers attack the enemies of the realm, 1 was hit. If I print this out now, Frankie now has 5 out of 10 hit points. And then we advance. We can print this out again. Frankie then moves on from the tower. So you can see the kind of sequence of commands that would allow this game to run, in a sense. You're going to be slowly piecing this together. I thought it would be nice to look at the front end before before we go in and look at how we're going to actually build this. So what's the command for quit? I think it's Q. Yes. Let's quit back out of that. So these are all the things we can do. Totally fine if you want to run the reference solution, play around with it, see what it does. I mean, it's up to you whether you want to play around with it a lot before you get started so that you get an idea about how things work, or if you want to, you can just use it when you need to verify what's happening. Because I think there's plenty of people who'd be happy to not ever run the reference solution and just be like, I'm going to follow the spec. Follow the spec and use the auto tests and create what I'm building. Okay, so underneath what we're doing, the castle defense has a series of different structures that it uses. So it has a realm. The realm, you know how like all the linked lists we've been using before had a head pointer. So I had a pointer pointing at the first element of the list. Now we actually have a structure that is holding that pointer. This is because sometimes we want a structure that manages other parts of the program. So we're going to have this realm structure, and the realm is a structure that has a pointer to the linked list of locations, and each location is a linked list node. The realm is not necessarily, it's not something we would consider to be a linked list node. We consider it to be a separate structure that governs the linked lists. And we also have enemies, which are linked list nodes as well, but they're used in a slightly different way from the locations. So here's a diagram of how this works. So am I blocking that? No, I'm not blocking that. That's good. So here is a struct. This is the realm struct. The realm struct always has these 2 pointers in it to begin with. So knowing that it has these 2 pointers in it, we're always going to assume that every setup of game of castle defense has one castle as one location and one lair as the other location, and they're always going to be both ends of the linked list. Everything else that we're going to add in is going to be the nodes in between those 2 nodes, but you have this kind of guarantee. Well, it's a guarantee so long as you code it the right way, that there will never be a node before the castle and there'll never be a node after the lair. Sorry, the lair should have a pointer to null at the end. We're not abandoning the standard structure of a linked list just because we have a pointer there. But what this means is, if we pass around a realm to functions and things, we know that every time we're using something that has a realm, we will know where the start of the list is, and we'll know where the end of the list is. So the end of the list is not as useful as the start of the list. The start of the list gives you access to all of the elements in the list, but we could check against this pointer to see whether, say, Matthews A would always know that its next pointer here is the same as the lair pointer, and so we know that we're the last location before the lair in that case. So we do have some usefulness in having the lair pointer like that. And so this governing structure, this kind of umbrella structure, allows us to keep information about the entire list. So if I wanted to, I could do something like, in here, have other information. So I could say, in here, I could say, how many locations have we added to the realm? How many towers have we added to the realm? I don't know if you need that. I'm pretty sure we don't even need that for anything in the spec. But let's say I needed it for a different reason. Then I could have that. So I could say there's 2 locations and 1 tower in this realm. So the towers and the locations are the same struct. They're location structs, but the towers have more information. So let's see. We've got a couple of questions there. QWERTY11 is saying, int addLocation realm and character name. Since it says return the number of locations in total, does it have something to do with making a function to count the location nodes? Looks like it, QWERTY. So addLocation is saying its return is the number of locations in total, and we're using this as well to test to make sure that things are working properly. So if I call addLocation twice, I expect on the second one to get a number 1 higher than I got on the previous one, right? Because we've just added 1 more location. So that's actually one way we can use the return value of that to actually check whether it's working or not. So if I had this one here with 5 locations at the moment, I called addLocation, the return value of that should be 6 after it's added the location. Duke is asking, are the 3 new nodes also in the realm? Well, it depends whether you consider anything to be in the realm or not. You could say that none of these are in the realm if you're thinking about the layout of computer memory. So the memory for the realm has enough memory to store these 2 pointers. I've got all this empty space in here as well, but the realm's not really going to have that. None of these locations are in the memory of the realm. But if you think about the overall abstract concept of what a realm is a big place. So Chicken's realm is massive because she obviously owns all of Australia, obviously. And you could say that all of these locations are part of the realm, But when we think about it in a programming sense, this struct just tells us where to find them, and then we can access them from there. So it depends on how you're thinking about it. If you're thinking about it, an abstract concept of a country with states in it, for example, or a region with cities in it, you could consider these things to be in the realm. But when we're thinking about at a programming sense, these are not actually in the realm's memory. These are all in their own allocated memory somewhere in memory, and the realm gives you access to it because there's a pointer to the first one, and then you can follow those pointers through the list here to get the rest of them. But there's not necessarily a piece of memory inside the realm which governs the castle, and another piece of memory that governs the quad. The castle just gives you, the pointer here just gives you the location of this struct. Sorry, the address. I shouldn't use the word location because I'm using it for something else. The address of this struct. This one has a next pointer that gives you the address of this one, etc. And you can see that in the code as well when you see the way that these are set up. Wait, they'll be set up in realm.c. That the struct realm has 2 pointers. If it has pointers, then the only thing that realm stores at the moment is memory addresses that allow you to get to the memory for the other things. The locations themselves have the name in them and the pointer to the next. So they're like pretty standard linked list nodes. They also have a pointer to an enemy structure, which is the start of the list of enemies, but we'll get to that in a second, right? Because we're just looking at the structure of the locations first. Yeah, so Duke's saying we don't need to add something in realm for add location. No, we don't. Well, it depends on what you do with realm. This is your code here in realm.c. If you're going to edit this and say int num locations, oh wait, that's, always be afraid when you create a variable and it auto completes, because that means this is already exists somewhere else. But maybe it'll be okay because it's inside a struct. So number of locations. So if I was tracking the number of locations, then I would need to change something in the realm as well. If I'm just adding something though without this, then yeah, I don't need to change the realm at all. I only need to go into the linked list that starts here, this linked list, loop through this linked list until I get to this spot just before the layer, and I insert there. I'm pretty sure that's the rules for addLocation. Wait, it'll be in the H file. We'll talk about that. So this is also, I'm sneaking in, showing you how we sort of navigate through this assignment and see what we're going to do. So a lot of the time when we're trying to figure out what we want to do, we can look through here, and our H file gives us a whole lot of information as well. So new tower, new enemy. Oh, I've skipped to stage 2. Add location. Add a new location to the realm. Given the name new location, add a realm and a realm to insert it into. So this is the name of the new location. This is the realm that I'm supposed to be inserting it into. Insert a new location node just above the layer. Return the number of locations in total. When I say above, we're referring to this. So the head of the list is the castle. The linked list pointers aim downwards through this to the layer. So you can think of this above and below kind of thing, like the layers at the bottom and the castles at the top. Sort of makes sense, I guess, when you think of a layer as being an underground layer, if you want to. And so if we add a location, it'll always be just before the layer in the list. So our add location function should be able to get through the list and find that gap between the two and do an insertion between them. If you're looking for the nitty-gritty functional code for how to do an insertion, check out the lectures. We have done one. The insertion you need to do for the assignment's not going to be that different from the lecture examples. So you can have a look at that and see if you think you've got a good understanding of how we did the insertion code there. You should be able to transfer that knowledge into doing it for the assignment. Other questions back there. I say QWERTY was asking about number of locations. I think we've talked about that. Eric is saying, when I try to get realm castle next as the start of the nodes, It says it is an uninitialized value, so how would you make a head of a linked list if it isn't initialized? So one of the issues you might be getting there is if you're going to realm castle next, let's go back, this is going to be much easier with a diagram. So realm here, castle. If we follow castle, we get here. If we follow next, we're following the next of castle. That's the location that you're looking at there. So if you say realm castle next, you're looking at this location. So it depends whether you've built a list before or not. If you haven't built anything yet, that should probably be pointing at the lair. So realm castle next will point to lair if nothing else has been added to the list yet. If you're still in the point where you're adding the locations, you can set realm castle next. So realm comes to here, castle comes to here, next is this pointer. You can set that to be a location if you've created something you want to put there. But if the castle itself has not had its next pointer set up, then realm castle next doesn't go anywhere. So it depends on whether the castle's next pointer has already been set up to aim at something or not. If it hasn't been set up to aim at something, then you may need to look at what you're trying to reference there. Because when you're saying realm castle next, you're referring to this pointer that leaves the castle and goes to its next node. So see if that's exactly what you definitely want to do, and see whether that works. Okay, so Jet's asking if you've done the new location function, because I think that's got something to do with it. And Eric is saying, yes, you just made new location point to saved memory pointed by a pointer that has nothing but a name. So I think what you're asking there is if you've made a location and you want to set the castle's next pointer to aim at that location, you should be able to do that by saying that what you said there, realm castle next. If you said realm castle next equals the location of this next part, then you would be changing this pointer to aim at that next struct. I wonder if I need to get a bit more visual with this. So let's say here we have our castle, we have our lair. The lair's next pointer is always going to be pointing at null, and in the beginning they should be set up like this. I can't remember how much of this you have to do. Let's see how much of this is implemented. So we have the location, we've got castle and lair. Location, new location. New realm will allocate memory for the realm itself, but then it will call new location for castle and new location for lair, which means new location here will have to exist first before this setup here, new realm, will be able to work. So it could be, it depends where your error is coming up. If your error is coming up here, then it means that there's something wrong with what's happening here, potentially. But see how it goes. Okay. I reckon if you're still having trouble with that, like I'm going to talk about abstract details, right? Things that allow everyone to understand what's going on here. But if you've got specific bugs in your code, then that's a good time to talk to your tutors at the help session. Labs are really good for talking to tutors at the moment, because the tutors are telling me that there's often a bit of spare time in labs, so you can get one-on-one time with your tutor. You're allowed to show your tutor your assignment code. You're not allowed to show anyone else your assignment code, so be careful about that. But you can definitely get into a breakout room with a tutor and say, okay, here's my code. I want you to look at it. This is the problem that I'm having. Don't just dump your code on the tutor and say it doesn't work, right? You do want to at least have had some time trying to solve your problems on your own, because if you don't do that, you won't learn the problem solving part of things. But you can definitely say to your tutor, okay, so I've tested this, And in these situations, it performs like this, so it seems to work. But when I do things this way, I get these kinds of errors. And so I'm not sure exactly what's causing that. Or you can be like, I think that this is what's causing that. Have a conversation about it. You can have back and forth. Talk to your tutor about it, and you'll get some good information from them. And so I suggest that labs are the best time to do that. But let's have a look at some other things that are happening. So Eric and Jet were talking about the new location. And Eric's saying that you'd done something probably like this. Memory allocation, put the name in, and then return the pointer, which means that that and that should have been able to be created. And then here, the realm castle next is saying the pointer, the next pointer that's inside castle, should equal the pointer to the layer. So that's saying connect these two up. So if we come back to this, the creation creates these two, which is this. That creates a new location. This creates a new location, but it sets up those. So let's have a look. So my realm, my realm is here, and it's got like a castle pointer and a layer pointer, and it sets up both of those here. So when it creates them, it says, okay, the castle one is this one called castle, the layer pointer points at this one, and then it says, okay, just to check to make sure neither of these is null. If neither of these is null, we connect them to each other. So realm castle next is the pointer that's inside castle, and we know that castle has a next because castle is a location struct, and it has a pointer to another location called next, which means we should be able to access that. We can't read anything from it because it has never been set up. It's never even been set up as a null, or depending on how you implement this part of it, but chances are there's nothing in it here. This is you taking that pointer and assigning it to this location, which is to say there's a next pointer in this. I now want it to aim at the layer, and that sets up our linked list as having a beginning pointed at by the castle pointer, so that's like the head, a pointer to another location, and that location has a pointer to null. Simple 2-element linked list there. It also has this, let me just switch to the arrays so you can see where my cursor is. It has this special structure that says I'm always just going to track where the first and last elements of this thing are so that we can manage it if we need to. So when I pass the realm to something, they can immediately see where the first and last items in that list are, and because they've got access to the first, they can then loop through everything in the list if necessary. So the realm was like saying, here, let me pass you this easy thing that has the addresses of all of the pieces that you need to work with. So instead of me needing to pass you the whole list or even just a pointer to the first element, I'll give you this package that has pointers to the first and last elements. And if you want to, depending on how you want to implement your assignment, you could put other information in the realm. These structs are yours to play around with. So you can add things to these. I would definitely not suggest removing anything from these unless you have a really good idea about what you wanted to replace it with. So we've put stuff in here that is definitely in the reference solution, and there's more stuff than this in most of these in our reference solution as well. Okay. So Eric's saying the error comes up when you type in a new location. So when you're trying to add a new location. So that's probably going to be, oh, is it this one? Or is it, in here? So rather than new location, add location. So add location is a specific thing that we have that says, add one location to the realm in a specific position. It's always going to be just before the layer. And so you need to do, so like the code that I showed you in the lecture and like some of the stuff you've done in the labs, you need to loop through to the point where you need to be, and then you need to insert there. Hello, chicken. Someone's supervising to make sure that I'm doing all right. Okay, Chapo Chap has asked, can we add structs to the code? If you really want to, you can add structs to the code. I don't think you necessarily need to, and I would be careful of if you're potentially complicating things a bit if you do. It might lead to an extra level of depth in your structs, but I don't see any particular reason why you can't if you don't, if you want to. Like if you're sure about what you're doing. Oh, like having a tower that is attached to the location. I think that would be possible. I'm just trying to think in my head, knowing the implementation, how possible that would be. Because I think there's two options for the tower. So you can have the tower as being some information that's in the location, but if you want that information to be in its own memory allocated thing somewhere else, I think that would still work. Like I'm not seeing off the top of my head any reason why that wouldn't work. It would mean you'd also have to be a bit careful about how you're going to free up the memory and stuff. And I think it kind of works nicely with the idea of the towers getting spent in a sense and then turning back into normal locations, is you could remove that component from the location once the tower has used up all of its charges or ammunition or whatever as we call it. So there's some possibility there, and I think that would be interesting to explore if you're looking into doing that. Duke is asking, should new location function return a point of location? Do you mean a pointer to a location? So let's have a look at new location. New location is returning a location, which is, if I remember my type defs, let's have a look at the type defs. Capital, oh wait, type defs are here. A location is the same thing as a pointer to a location. So yes, the new location should return a pointer to the location. If you're unsure about what pointer it should return, you can have a look here, and it should be commented reasonably well. New tower, new enemy, new realm. Oh wait, it's not in the H file because it is not a function that the H file uses. So it's only in the C file. It's not accessible outside the C file. That's what this word static means, actually. Static says we are only accessible inside the file we're in, which means that no other files can use this function. So new location is here. Return a new location created with memory allocation. So this is what this thing is saying, is like allocate some memory for a location and return the pointer to it. So I'm pretty sure this thing is expecting to return the pointer to that location, and that makes sense here because we called new location on castle, and then we stored its location in the castle pointer, so that's highly likely to be the location that it's supposed to be in. Okay. Alright, there's a bit of conversation going on there, but I think Duke is asking if addLocation makes a new location in the linked list but not in the realm. Well, I'm not sure. It depends on what you mean by that question. Because if we look at this, no locations are in the realm. All of the locations are in their own allocated memory. So if something makes a new location, it's going to make it somewhere in allocated memory. So if you're using the new location function, and the new location has, as we read a second ago, allocated memory, then it's not in the realm. It's somewhere here, and it's in the linked list. So I think that's correct in what you're saying. It makes a new location in the linked list, but not in the realm. In fact, no locations are in the realm. Like, the realm never stores any locations. The realm stores pointers and the pointers say where the locations are. So we can access the locations via the pointers in there, but that doesn't mean that any of these are in the realm's memory itself, and they're not in the realm struct, you know. So we can think of it like that. These are in other parts of memory, and these give us access to them. Eric, I think there is a help session today, but I'm not sure if it's already happened because we're pretty late in the afternoon. Tom, do you remember? We can check this. Help sessions. Week 8. Oh, there isn't one today because we're in the first week of an assignment cycle. And if there was one today, it would have been 11 a.m. to 3 p.m. So unfortunately, no help today. But there will be help soon, and you can always ask a question on the forums at the moment because the forums haven't heated up yet for the assignment, but they will soon. Okay, so let's go back to what we're doing here. So this is the overall structure of the assignment. Sorry, Leon's asking a question. What does the ++ mean on the Thursday spots? I think you mean these? I can't remember. Does that, Tom, does that mean that it's shared with other subjects? Or is that a help session that is at those times has more staff on it, I think. Yeah, extra tutors. So during the peak times when the assignments are getting a lot of work, so the second and third week of the assignment, there'll be extra tutors at those ones. So chances are wait times will be a little bit lower on those ones. Okay, so this is the structure that we're going to be using here. So we have a struct that gives us access to a linked list, and we can consider the castle pointer to be the same as the head pointer that we've been using in other linked lists. It gets us to the first element of the list, and then we can access it. We also have the layer pointer. If we want to use that, we can detect where the layer is, which is kind of handy because if we're going to insert just before the layer, and we know which one the layer is via this pointer, we can compare against it and things like that. So little tricks like that we can get to if we're thinking and planning on what we're doing. I said that we were only going to take 45 minutes to go through the slides. I was wrong, because I decided to answer a lot of questions along the way. But I think it's worth it. I think it's worth answering those questions because giving you some better understanding is going to give anyone else who watches this better understanding. So I just move my face over there so that I'm out of the way of the diagram. Let's zoom in a little bit. So we're zooming in on an individual location here. So here's the quad, and at this point in time the quad has an enemy in it, and the enemy is Frankie, and it also has another enemy called Star Fox because the enemies are foxes, right? So that was the only other fox I could think of off the top of my head. I think Tails from Sonic is another fox, and so we'll see if Tails comes in at some point. But you know, in this diagram didn't have enough space for him. Okay, so notice that the quad has a pointer coming off it to an enemy structure, and since an enemy structure is a linked list node, it can have other nodes. I don't have it shown here, but we could have more nodes coming off the Star Fox, or Star Fox's next pointer could be null, saying, okay, this is the last enemy here. So you can see that kind of what we're building here is a little bit like a two-dimensional linked list. But it's not, and I wouldn't think of this the same way that we thought of a two-dimensional array in Freefall. It's a very, very different structure, because the two-dimensional array in Freefall was a single structure that's considered to be a grid. This is very much not that. This is a single structure, which is a linked list, and in each of these is a pointer that then looks at another linked list. So I would try to separate them in my mind, because they're not, it's not a two-dimensional structure like a map, because when you get this situation with multiple locations, some of them have enemies, some of them don't have enemies, and things like that. So it's more like every location has the possibility of having some enemies in it. And so if it has the possibility of having some enemies in it, that means it has a linked list in it that may or may not be empty. And that's a better way of thinking of it than a two-dimensional structure. Because when we think of a two-dimensional structure, we assume that all of these are the same size, which means that would be like assuming that there's the same number of enemies at every location, which is not usually going to be the case. So any tower location is usually going to end up with less enemies than other locations, and it really depends on how the game itself has spawned enemies, and that would be via the command E that adds an enemy to the game somewhere. Yeah, so each enemy itself as a linked list node might have some information. So in detail in here, it'll have a string for its name. Let's have a look at the actual code. The struct for an enemy doesn't have any information yet, so I'm actually giving away some possibilities for what you might want, knowing that when we created an enemy, I think we just advanced Frankie multiple times there, and we checked the names as well. Okay, we added an enemy, we used a name in it, and we had a maximum hit points here, and so we can see the maximum hit points. And even after we hit them, we still know what the maximum is and what their current hit points are. So we have this suggestion that we're probably going to be storing a lot of information in here. We definitely know that we're going to store a string. Looks like we're storing 2 integers here. I can't remember if the spec is exactly clear on whether they're integers or floats, but I'm pretty sure it's integers. So we have some really obvious clues as to what the contents of this struct enemy might be. Obviously, we have left this out because we want you to get some practice in building the struct yourself. The only thing we've got in here to make sure this thing works is that the struct enemy has an enemy pointer in it. So it has an enemy pointer, so it can aim at another struct, which means it's a linked list node. Duke is asking, is it possible to put multiple enemies in the same location? Definitely. Yes, that's why this is a linked list. So as you can see here, there's a linked list here with multiple locations. Each location can have multiple enemies. If this is confusing, then play around with stage 1 first, because stage 1 doesn't involve any enemies. It just involves the linked list, the single linked list. And then when we start doing linked lists that start from other linked lists, so this linked list node starts a new linked list here, then that's where it gets a little bit more complicated, and you've got to like think a little bit more about how you want to put it together. Dylan's asking, how do we pass the auto tests? You pass the auto tests by writing the correct code. I'm not sure if you had more information than that you wanted to ask. Yeah, you did. Do we need to add our own code in the test file? Yes, you do. I will talk about that in a moment. I think that's actually coming up in a second. Okay, how to get started on the assignment. I suggest that one of the easiest ways to get started, I've already done it here. You know what I'm going to do? I'm going to delete everything there. And I'll go up 1, oops, ls, and I will... What is it? Someone's hungry. Okay. Oops. If I want to remove a directory, I need to use the be careful with using -r, but I need to use -r if I want to remove a directory. Okay, so let's do this from scratch. I'm in my COMP1511 directory, and I haven't done anything yet. So let's make a directory called Castle Defense, and I'll change into that directory Just tab completing, speeding myself up. This is empty at the moment, but I'm in the castle defense directory. So what I want to do now is grab the package of files from CSE. So 1511 setup castle defense. It's either setup castle defense or castle defense setup. We'll find out. Oh, I think that was the right one. ls shows me my files. Ooh. Let me finish, Joseph. I'll talk about what we're talking about with pointers there in a second. But that is an interesting question, and I'll show you the answer to it in a second. Okay. When you do this, you get all of these files. So this is a big project with lots of files. Note that in my highlighting, at least, a lot of these are pale blue, and only 2 of them are white. So you'll have noticed that in all the other directories, so let's go cd, I think, was it lecture 12 had multiple different programs in it? Oops. / lecture 12. ls here, you'll see all the white files are the ones that we edited or could edit, the backup files as well. The green ones are the ones that can run. We've got this extra color here, the cyan. What that actually means is those files are not editable by you. They're actually links to files that we own. And so this is to help you out in a sense, that you can't edit those files and you shouldn't edit those files. There's only 2 editable files that will be submitted for the assignment, is these 2 C files. Everything else you can't submit. So be careful if you look at something like realm.h and you go, I want to change something in realm.h, because that will actually break your connection to the assignment in a sense. And anything that you write in realm.h will be destroyed when you submit. Well, it won't be destroyed on your computer, but it won't be taken as part of your submission. So if you're doing this on your own computer and you're copying all the files from us, the zip files, you've got to make sure that even though you've got these other files there, that you're really only editing these. That should make it easier because you only have to edit those, and the others give you a guide to what's going on. Oh, Tom's saying if we want to, we can run ls with some extra arguments here. LSLA allows us to see a full listing with all the details, and we can see here that capture.c links to web cs1511, that's our directory, activities castle defense capture.c, and likewise. So these are where we store the files that you can read but you can't edit. And the nice thing about that also is if something goes really wrong, like it's rare that this happens, but it's possible. If something goes wrong to a level where we need to change these files, if we change these files, you don't have to do anything because the automatic linking to these will get you the newest version of these files no matter what. So the easiest way to do the assignment is to do it on something like VLab or on the CSE computers, because that way you'll have access to the most current files whenever you want to use them. Joseph was asking about where the asterisk goes on pointers. Oops, I have to reload that. And why we have it here rather than on the struct side. So why is it there rather than there? I've showed an example of this before actually, but let me just start a new one. I'm gonna have to save this as a C file. Oops. Up here. Just gonna save it as a C file so that it gives me my syntax highlighting. So if I'm declaring several integer pointers, for example, and I do integer pointer A, B, C, what I'm going to get if I do this is one integer pointer and 2 normal integers. So A is a pointer, B and C are normal integers. So this is the issue with putting the star on that side. So if we put the star on the left hand side, it gives us the implication that that type is going to work for everything here, but it's not actually true, which is why we keep it on the right hand side here. And now it's really clear that this one's a pointer and these are not pointers, and that's what it will actually do when it compiles. So that's the thing about where we put the star. And I know that it can get really confusing because we go, well, this is the type and this is the variable name, and it's like, well, why would we put a space in the middle of the type and not a space here? But we do it for this reason, so that if we were to do something like this, we wouldn't get confused. Yeah, cool. So hopefully that helps there. Where was that? There was another question there. Dylan was asking about tests. Let me get to that. We'll get to that in the slides, actually. Okay, so we've talked about the things that can be edited, and then the other files are things that you're going to use. Oops, my face is covering the text. I moved it there because it was covering one of the diagrams. So you get this package of files that has lots of stuff. A lot of those you don't even need to read. I would specifically say the capture.h and the capture.c are not important for you to read. They're specific code that we wrote so that when you're doing your testing, you can pretty easily grab the output that you're meant to be printing out from each of your functions and test whether it's the correct output or not. So I think I've said a little bit about what's in the files, but a lot of the files that we're working with here. So this is like a multi-file project. Oh, everyone's retracting their messages. I look over, it's like, oh, people asking questions, but like maybe I've answered your questions already, which is good. Hopefully, yeah. So you can see a series of different files that we're using. So capture.c, capture.h, as I said, this is code specifically to read what you're sending to standard output. So don't worry about it. It's full on, right? I could nearly say that as you're working on this, you could just not look at them at all, because we've got some examples about how to use them anyway. So this is the interactive program. So this is the thing that I was using earlier that takes in these inputs and does things. You also don't need to look at this because it's not super it's not super important how it does what it does. We just trust it to do what it does. So I'm going to close that one as well. realm.c, realm.h, these you are going to need to use. realm.c, you're going to be making changes to. A lot of changes is where the majority of the code in your assignment goes. And realm.h is a lot of the documentation for exactly what those things do. Hugo's asking if the location structs have been defined in testrealm.c. So let me just say what testrealm.h and testrealm.c are. So testrealm.h and testrealm.c. Oh, sorry. After I deleted everything and reloaded it, I have to reload some of these. These are a different project that you can compile. Someone's trying to distract me because she's hungry. We'll do a chicken feeding session in a second once I finish talking about this. So this will see realm.h, it will see testrealm.h, and it'll use stuff from capture as well. So having a look here, we'll see that it does not have any structs in it. And I think that it's pretty clear here. You can also see you should not declare any structs from realm.c here. Declaring structs from realm.c in this function is against the rules of the assignment. It will also break a whole bunch of stuff. So it's like, actually, I think it might compile having two declarations of the same struct, so long as they don't include each other, is technically possible, but super dangerous. So what we're doing is we're testing as if we don't know what's in the structs, because we're not testing at that level. So we're not testing to see what exactly is in the structs. What we're doing is we're testing to see what the inputs and outputs of all the functions are, and whether they whether they can run properly. Yeah, as Tom's saying, it will compile if you redefine the structs in here. Redeclare, sorry. But it'll... It's like saying it's safe to drive a car if you put a rag in the petrol tank and then light the other end on fire. The car's still going to run for a little while. until that flame gets down the other end of the rag and sets the petrol tank on fire. Well, it's more than fire, it'll explode. It will technically still run at that point. So that's what it's at that level of danger of what you can possibly do with your code if you redeclare the same structs. So Jet saying lose marks for this. If you redeclare the structs in test realm, so if you're Tom, if we go fast enough we would stop. Yeah, so if you redeclare the structs in here in the test file, then you potentially cause some really huge problems. And yes, you'll definitely lose marks for testing on that. I'm not sure if we'll take marks off your other parts of your assignment, possibly style marks and testing marks, depending on what you're doing here. So just don't do it because it's not part of the assignment. What we're supposed to be doing here in the tests is note that there is a main function in testrealm.c. That means there's two ways to compile this project. One way is to compile it with main.c. And you know, we were talking about multi-file projects. This is a classic multi-file project, but it's actually two multi-file projects. So the realm.c is going to be in both projects. If you're doing it for yourself, you would do your realm.c with testrealm.c, and then you could run your tests to see how things are going. We also have something with the auto tests where we compile your testrealm.c with our realm.c. And we've made a specific realm.c that's broken in particular ways. And what the auto tests are with our semi-broken realm.c is to see whether you can find out in what ways it's broken. And you can do that by running the correct tests. So for example here, there's an example that shows you how to do it. We do addLocation into a new realm. So we've made a new realm called test realm. We do addLocation into test realm, and we store the number. If the number of locations that comes out of the test realm is incorrect, then we would do this printf saying does not follow spec. So we've got these defines. Are they in? Oops, I was in the wrong one. Here, test realm.h. Oh no, the defines are in the C. I thought they were in the H file. No, I was in the wrong spot. Yeah, they're in the H file. So follow spec or does not follow spec are the things that get printed out. And so we just did this so that we wouldn't have typos causing any issues with that. So you can just use this hash define to say whether something did or didn't follow the spec correctly. And we might actually throw a test at you which does addLocation incorrectly, and then you're supposed to print out does not follow spec if you see that it didn't follow the spec correctly. And we've said here are some other things you might want to test. Does addLocation return the correct amount for lots of locations? So this is just adding one location. And so what if we added 3 or 4 locations? Is it still tracking the right number as it gets higher? And so we say you should probably write a test here, and you can do a test pretty similar to this. You can do anything you want in these tests so long as you do some running of the functions that are in realm.c, get some information from them, compile this information into an if statement that says whether it does or doesn't follow the spec. We've also said that if at any point in this test, so testing the addLocation, if it doesn't follow spec at any point, we're allowed to return at this point, which is to say we don't need to run any more tests because we've said this does not follow the spec. So we had a question there. Rebecca said, still confused about how the addLocation works. Is it like we create a new location between castle and lair and connect them together? Yes. But it's not necessarily between castle and lair, because there might be more space between castle and lair like this. addLocation is very specific, and it says you will add something just before the lair. So it would be an insertion between the final thing and the lair. So that's where the new object is going to appear, the new location. So addLocation says insert something into this linked list in this location. So you can look up the insertion code that we did, and we also did the alphabetical insertion, which looked for a specific position and then inserted there. You're going to have to modify it a bit to match inserting into the one just before the layer. There's different tests you have to do, but the bulk of the code is probably going to be quite similar. Okay, so we're looking at the files and what they did. Two ways to compile. You can compile the interactive program like so, or you can compile the test. Oh, actually, now that I think about this, pretty sure we would also have to compile, what was it called again? Capture. So I'm just going to edit my slides there. We need capture.c if we're going to do the text capture as well there. We don't always have to run this. Like, this is nice if we want to automatically test our own functions. So you can test your own functions and you can see whether your own functions are working using your own test realm. Because what this is going to do is it's going to hook up to realm.c. It's going to say, okay, which functions are you providing? I will try to run those functions and see whether they meet spec or not. And so this is our first kind of time to show you a lot of what is in the background when we write auto tests. So we write auto tests in a similar way where we say, what should this program do or not do? How do we run your programs to see whether they work or not? And then we'll report back to you whether they meet the specification that we've asked you to do or not. Test realm is like its own auto test. And so what it does is it runs the functions in realm.c and it says whether they are actually performing correctly or not. You have to write the functionality to find out whether it's actually doing that right or not. So there's a bit of that you need to work on. And there's examples in there to show you some of the starting points for that. On top of that, we have auto tests that will actually test your test realm. So let me just... Oh, by the way, that idea of us going through and testing individual functions from a code file that we've created is often called unit testing. So unit testing means that there's little units of code and we're testing each one on its own. So for example, in here, we're testing addLocation. So the unit that we're testing is the addLocation function. We're not testing any other functions other than addLocation. And so this is going to call addLocation and test whether it follows spec. And then we can call it a few more times for other reasons and then test whether it follows spec. And you can add your own tests here and say, all right, there's other things that I thought we might need to test. And so you might actually find this out via the auto testing that you fail auto tests because you're not testing all of the possible ways that this could go right or wrong. So you might be saying something does follow spec when it doesn't, or you're saying something doesn't follow spec when it does. So that's why we've made a custom version of the assignment that is broken in very specific ways so that you can test your test realm against it and see whether your test realm can accurately detect whether something does or doesn't follow the spec. Liang, yes, chicken is complaining a lot right now for food. So is it about time to give chicken some food? So let's go on break. I'm assuming people want to see chicken being fed at the moment. I think it's become an important ritual as part of COMP1511 that we always watch chicken eating. So I'm gonna go get her food and give her a little bit of a feed, and we will take a break, and I will take a break from talking while we do that, and then we'll come back and look at the rest of the things in the assignment. So I will be right back. Let's see if that camera's in the right place. Looks like that'll work. Oh, the complaining is coming up. Alright, I'll be back. I'll give chicken some food. Be right back. Is that the right spot? That's the right spot. Yep. I like the conversation that I'm reading there. All right. Finished our little meal. That's like how we know how long the break is now. All right, just gonna move the camera. Alrighty. We are back. And there was a bit of discussion there about addLocation and what its next pointer was going to be. I think there's a lot of help there from Shrey, which is giving people a lot of ideas about what we might be doing there. I wonder if we want some imagery to help out. With that. Okay, so let's say we have this situation here. This is the simplest situation where we might add a location. So let's create a new location. Here, I'm going to call it Q for the quad, because the quad was the first place that that Frankie was seen, and we know that the quad must be put into the list just before the layer. So what we would do is we would do a standard insertion where we would link up the quad between the layer and whatever was before the layer. So at the moment the castle is before the layer, so we would copy its next pointer into there, and then we would take the castle's next pointer and we would aim it at the thing that we just created. And that is exactly the algorithm that I was telling you about how to insert something into the linked list. The first thing that you do is you take the pointer from the thing that's before you and copy it, and then you take the pointer from the thing that's before you and you change it to now point at yourself, and then you'll be able to insert something just before the layer. And if we insert another object here, that's K for K17, we would do the same thing. We would find the object that's before where we want to insert, and we know that there's an object after where we want to insert, and we would say the next of this one has to copy this one's next, and then this one's next then shifts to us. I'm not going to do the code. I don't want to give away the actual assignment, but this is exactly what I was teaching the other day about how to insert, right? And the insertion's the same, so long as you can find out where you need to insert. That's there's two things you have to do here. Like, the actual insertion code is nearly exactly the same as the insertion code that I've taught you, but you need to be able to find out where to do the insertion. So it might be a matter of going back through the lectures and looking at my insertion code in the Battle Royale and seeing how that works. Or if you don't want to do it via the lectures, the labs have questions about inserting, and so you can have a look at those, or you can take your partial solutions of those to your tutor and talk to them about it, and then get an idea about exactly how to insert a node anywhere you want to. And then think about, if you do know how to insert a node anywhere you want to, how do you insert a node always into this position just before the layer? So there's two different things to think about, right? So I would personally try to get my idea that I can insert a node anywhere into a list first, and then say, okay, if I know how to insert something, then how do I find this exact point to insert? Because that way it's simpler if you separate into two things. And you'll note that's exactly how I taught it in the lectures. So I taught you how to insert at a pointer. So if I found a pointer to a particular object, I can insert afterwards. And then I said, if we wanted to do this alphabetically, then we would look through the list and find our position we wanted to insert, and then insert. So basically, stage one is the example and the code in the lectures is not exactly, because I'm never going to do it exactly, but it's a reasonable match for stage one. You can get a lot of clues about how to do stage one from the lecture example. Jet's like, looks like Mark's going to spoil it. I didn't, well, I may have spoiled it a little bit. I mean, like, if you follow my instructions exactly and you can translate them into code, you can get most of this done. You still need to be able to find that position, and you still need to be able to actually know how to move these pointers around. But that's something that you can do if you look at my examples in lectures and look at the labs and the tutes. Ask your tutor for more help if you want to next week in the lab. Labs next week are obviously going to have a whole lot of linked list stuff in them, because the entire set of lectures this week were about linked lists. So if you want to get more practice on this, it's coming. You will get this practice. Yeah. Yeah, as Shrey is saying, thinking about the abstract nature of the linked lists is important, and if you haven't got that part in your head and you know what you want to do with the pointers, it's very, very hard to code them. So it's much better to visualize it and then say, okay, step by step by step, this is what I did. Then I go to my code and I say, okay, if those were the steps I needed to do, how do I change the addresses of pointers? You know, because that's a lot of it. Is like, if I set a pointer to a different value from what it was before, that moves where the pointer's aiming. And you'll note that most everything we did here was just moving where pointers were aiming. There was some memory allocation, but then there was like, this one used to point there, and then it ended up pointing here, which means I changed what Castle's next pointer was, right? So once we get into the feel of that, then we go, okay, changing the value of the pointer is changing where it aims. And knowing where it should aim next is me going to a piece of paper and drawing this out and then trying to figure out where it's going to be. Okay, so Eric's saying new location only has the information of the new location's name, which will be inputted by the user, right? Yes, that's the only thing it needs as well. Duke's saying there can't be a space as well. So if you put spaces, I think that it's not necessarily that it's going to try to make 3 locations. It will probably reject the rest of the rest of the things after the space. It depends how that was implemented. You might actually be okay with, you know what? Let's find out. 1511. So this is one of the things that the reference solution is really good for. 1511 castle defense. So let's say my house. Oh, there you go. Nice complete answer from the reference solution. It says to us, place names will never contain space. You do not need to handle this error in your code. So that's a really, really nice thing for the reference solution to tell us. Don't worry about it. Won't be a problem. That means you can happily do something like a scanf, knowing that we're not going to throw a second word at you that's going to throw off your next command or anything like that. You're just going to get strings without spaces in them. Actually, I don't think you even do any scanf. You won't ever do a scanf. You'll get given a string that doesn't have spaces in it. Yeah. Yeah, Tom. I did notice that. I wasn't going to call it out because I figured it's not that big a deal. Normally, we would put a new line on the end of our error messages, but it's fine. It's a good error message that still gives everyone the information that they need. Okay. So Hugo's wondering, how comprehensive does the auto test have to be for the location addition? So I assume that you're talking about the tests that you write. It doesn't have to be super comprehensive. It depends on what kind of marks you're looking at. So addLocation doesn't have a huge amount of information that it gives back. So it gives back the information on the number of things that are in the list after it's added something. So you can test that number under different circumstances and see how that works. I guess if you wanted to be really comprehensive, you could add several locations and then loop through or print the output and test whether the output is correct or not. You'd have to do a bit of playing around with capture. There's some examples of capture here that say if you print the test realm, then you can capture into a string what was actually printed out in text. And so you can do this kind of thing where you can say, did it print out all of the locations that I just added the right way? And so that might be another test that you could do here if you wanted to. Up to you, but I think if you want to, you can just go as far as the auto tests are pushing you. If you're trying to get 100% in this assignment, then I would get quite specific. I would say, what are the issues that people are likely to cause with this function? What are what we call the edge cases that are going to happen with this function? So what happens when we add location the first time? What happens if we add location after several iterations? What happens if we add location after we've removed some things? Although I don't think we can remove locations. Yeah, but you'd want to test other information. So let's make sure that addLocation always adds in the correct position, which is one before the layer. So what if someone wrote addLocation and it always added after the castle instead of before the layer? So that's something that doesn't meet the spec. But if we're only testing the number, it would pass all the other tests. So you can decide how deep and comprehensive you want to go with these, and it shouldn't be that hard to pick up some of these things. It's a matter of guessing the ways that you think this is going to go wrong. We have had discussions before about running this assignment as like a sort of a competition where you can get more marks for writing tests based on how many other people in the course you catch out with your tests. So you can test things that you think are going to be the common mistakes that other people would make. But we're not doing that. We're just doing it against our testing. But you can see some of the options for what might go wrong there. I would be careful not to go too deep down the rabbit hole. I've talked before about QA engineers, right? People who test for a living, and how that's a full-time job. And you can get caught up in that if you want, but we don't want people to get too caught up in that. We do want you to learn that it will be your responsibility to test your own code, but you don't have to go like absolutely comprehensive. Like, note here that we've said just do 3 tests, you know, so we're not saying that you have to do like 18 tests here. So the general suggestion is just to do a few and see what the auto tests are suggesting that we think that you should test against. So you may find that you keep failing the auto test either by saying that something does pass the test or doesn't, and then you can see, okay, what are the things that it might be testing that's causing those issues. I can't remember if the auto tests actually say exactly what the commands were. Oh no, they can't. They won't say what the commands were or anything, because they're providing the functionality to you and you need to test it. So that's you can work off whether or not you're meeting the spec or not, and you can just try to think about which ways it could go wrong. Chap's asking, to test if it adds before the layer, can we access the realm? Oh, Tom said they do say what they are. So the auto tests are going to give you a lot of clues as to why things are or aren't working. Chap, you cannot access the realm. What you can do is you can print out the realm. So you can only access the functions, you can't access the structs. So if you want to test what's in a realm, you can do a print realm test. So if you have an implementation you know works, like for example the 1511 castle defense, you can run that and you can look at the output that prints out and you go, okay, that's correct. So this thing should print out the same thing that does. Yeah. So that's one way that you can do things. So you can say, I'm going to make sure that you follow the same thing that the reference implementation does, but you do still want to make sure that while you're doing that, you're testing specific things. So you can't just go, okay, run some stuff and you have to have the same output. You might be able to test some things that way, but you do kind of want to say, okay, there's certain things we want to look at and we want to test those things. So QWERTY11 is saying the auto tests we have to make are strongly related to using if statements. I would say so, because I would say you would perform some task and then you would check if the result coming out of that task was what you expected. So if you expected after adding several, so let's say you call this thing 3 times and then you check if this is 6. That could be a decent one here. Like maybe you don't want to do it exactly that number of times or something, but you could do it like 100 times if you wanted to, right? Because this is a clue here. Does addLocation return the correct amount for lots of locations? So maybe there's an error in our implementation that we've put in that only happens after a certain number of locations. You can play around with the auto test and see whether you can trigger the error that we've left a clue for you that there's an error. So the thing about this is we're being very nice to you because you're still learning, so we're actually telling you a bit of information about what the error is, and so all you have to do is figure out how to test it. When we get out into the real world, basically your code just doesn't work, and you have to figure out how to test all of your individual functions that you've created to see which one is the one that's working, which one the one isn't. Because it could be that, you know, addLocation is one thing that we're testing, but we're also testing new realm and addLocation and new location. So there's 3 functions in there, and if we were to be really careful, we test each of them separately. You know, we're not testing new realm and new location here because we think that addLocation should be able to test those other things. But likewise, print realm is going to be tested, new enemy is going to be tested, right? So you can do your own tests on each of these to make sure that they actually do what they're supposed to do. So that's what we're going to be doing in the testing section. I think that's exactly what I was going to talk about here anyway. So we're sort of segued into that. Let me go back and see if there's anything that we need to think about. Suggestion, and I think that everyone who has spent a decent amount of time with the first assignment will be reasonably sure of this, is that the stages escalate in terms of difficulty. They also escalate in terms of like requirements, in a sense, in that if you haven't done say stage 1 and 2, stage 3 kind of doesn't work. Like if you can't add locations to the list, there's no adding enemies to the locations because there's no locations to add the enemies to. So it's this kind of like do the stages in order. That's they're done that way, and they're done in this kind of like do this thing, then do this thing, and then you'll be able to move on to the next thing after that. They do get harder as they go, and some of them jump into interesting territory with sort of logical ideas that you can play around with, abstract ideas. If you get to stage 4 and 5, there's some text search going on there as well, which is interesting as well. So that will use a lot of potentially you can use libraries, potentially you can use knowledge of arrays and other things like that to be able to work with those strings. So there's a bit of stuff going on there. Okay, so we've talked about testing as well. No new questions at the moment, which is good. I was also going to talk a little bit about marks breakdown, because people usually want to know about what exactly you need to do for the marks. The marks are not the same as the first assignment because there's more stages in the second assignment. There's also more marks in general. The total assignment is worth 25% of the course. So when you consider that it's a 3-week long assignment and it's worth a quarter of the entire course, that's roughly correct. In terms of the amount of time we spend, 10 weeks in the course, and you've got 3 weeks for this assignment, it sort of adds up in time to be about the right amount. Liang Chao saying, in the exam, can't do question 1, skip to question 2, question 2, use the results from question 1. Yeah. I mean, it is a bit like that. But I mean, at least the way that we're marking this is if you can do stage 1, that is a pass mark. So we are ranking these in terms of what we consider to be the required competency for a student. Because when we get to stage 4 and 5, it's kind of like, here are some fun things that you can do with programming that are basically like challenge exercises. So we have no expectation that the majority of the course should even attempt stage 5. It's not necessary at all, in the same way that it's not necessary to attempt the challenge questions and things like that. Oh, big question. Eric is asking questions for later on. How do we practice for the exams with arrays and linked lists? Later on, I am going to open up a section of the website, which is revision, that has a whole bunch of extra questions aimed at specific topics. So there'll be questions on strings, there'll be questions on arrays, questions on linked lists, and they should be things that are in a similar format to the labs, but not the same questions as the labs, so you can try out your skills on different types of things. The format for questions that have been in the labs and the weekly tests all the way along is the same format that we'll be using for the exam. So you can think of it as your exam being a series of lab exercises that start easy and then they escalate in difficulty, and we expect that everyone stops at some point and says, okay, this is too hard and I won't keep going. So that's where we do it. It's like lab exercises that just get harder. Not that much different from a lab itself. We structure the labs like that. The first question in the lab's usually pretty easy, and the final question might be crack a substitution cipher, which is harder than assignment 1 was. So escalating scale of difficulty. So you can start from the beginning and you can go until you hit a point where you go, I'm not sure I understand what's going on here anymore. And that's the point where you can stop and you go, all right, I went as far as I thought I could go, and that's fine. That's how we assess people in this course. Taylor is saying, if we don't implement later stages, can we still access marks for testing if we write tests for those later stages? Yes, you can. That's one of the tricks, the freebie marks, is that if you test stages that you didn't write, you can still get marks for them. So when we consider the 10% testing mark, if you only test stage 1, you're looking at probably getting about half of the testing mark. But if you test all 5 stages, then you can probably get up to 10% in the testing mark. Even if you can't implement those stages yourself, you can still get the full testing mark for it. So you can kind of boost your marks a little bit. If you find that you've reached what you feel is your technical limit, and you're like, okay, that stuff there is too hard to understand for me right now. Give me a couple of years in computer science and I'll come back and ace this stuff, no worries. But for now, look, too much, I've got other work I have to do. However, I can read the spec and I know how things should answer. I can do my testing. And so yeah, you can do that, and you can run your testing against the auto test, and you might be able to get a marks boost there that can shift you between different marks brackets, which might be nice. So you can actually get higher marks than you're expected to get based on your performance if you've done really good testing. And then you can think about that future that I was saying as a quality assurance, a QA engineer, because you might actually have found a particular aptitude for testing that you didn't realize before. Up to you though. Yeah. Dylan's asking the date of our exam. I know the date, but I can't remember it. I don't want to open my Google Calendar on a stream. It's got all the other things that I'm doing. You'll be like, why is Mark going there at this time? But it's either the Friday, the very first day of the exam. Yeah, there you go. Friday the 14th. We are nearly always the very first day of the exam period, because COMP1511 is one of the biggest courses at UNSW. So they always put the biggest courses on first, and then they settle the calendar conflicts for the smaller courses later on in the exam period. So you'll find that usually based on the number of people that are in the course, that's when it'll be in the exam period. Also, if we have to mark 750 exams by the end of the exam period, they better put us on the first day. Otherwise the stuff doesn't get marked and you don't get your marks back. Yeah, so Leon's saying Friday the 14th is most likely correct. Tom's going to confirm. Okay, so in terms of marks, yeah, if you want to start studying before the term finishes, then this assignment is due at the end of week 10, and then the exam is going to be the end of week 11, so there's going to be like just 1 week of study in between the two. Having said that, know that our exam is an open book take-home exam, so you can literally look at an exam question, watch one of my lectures that covers that exam question, and then implement it. Like that's how we're running it at the moment, because there's no way to do a closed book exam online. So we're like, fine, that's cool. Use the resources. My resources are publicly available, so they're the things that you are potentially going to use. Like you could go on to other subjects in computing, and you could do COMP1521 or COMP2511 or something and say, oh, really need to revise on linked lists. Well, let me go back. Mark's got a few hours worth of linked list talking. I'll go back and I'll watch that again, and then I'll be able to understand this thing for this later subject. That's totally fine, and that's one of the things that we would do as a computer scientist, is we revise what we're doing before we attempt to do it. So your exam's going to be in that format, rather than a how much can you remember in 3 hours kind of exam that we would usually do. I'll talk more about the exam later. I actually have an entire lecture about the exam that picks it apart and tells you about how it's going to run. Taylor's asking if the open book exam means it's harder. It's a little bit harder than the old exam, but you will still get higher marks in this than you would have in the other exam. I don't know this for certain, but that's what I saw in term 1, is I saw people with higher marks than I normally would see in the exam, because usually the exam is 3 hours closed book. Like, you think about what you can do in 3 hours without being able to look anything up, versus having a 24-hour period so you can take breaks in between questions, and you can even sleep and wake up the next day and solve a problem if you wake up early enough, because we're probably going to do a 9 a.m. to 9 a.m. thing. You're definitely going to be able to solve harder problems, so it'll balance out. I mean, I did see, I think, a higher average mark than I normally would last term, even though it was pass-fail, so we didn't publicize it. I still looked at the numbers. Liang, yes, the exam is 24 hours. It is not 24 hours worth of work. It's about 3 hours worth of work. It's almost like don't wake up the next day. I did not enjoy. Okay, so wake up the next day and trying to work again before a 9 a.m. deadline is very difficult. But the 24 hours is like that just because we're all in different time zones. So I didn't want to unfairly disadvantage anyone who's in the US, for example, because we do have some people in the US who are studying COMP1511. So if I did what I think of as like, okay, here's a 3-hour window, then someone has to wake up at 3 a.m. and do an exam for 3 hours from 3 a.m. to 6 a.m. And I would consider that to be unfairly disadvantaging someone, because don't ask me to be functional in that particular time period or anything like that. Hugo's asking if the course is pass-fail. It is not pass-fail. You're going to get a number this term. So you will get a number, and you will get the categories between pass, credit, distinction, high distinction. So you will get a full proper mark from UNSW from this course this time. Yeah. So we have to be more careful with that this time around as well. But I mean, technically last time we did have a number for every student, but it wasn't publicized because there was too much potential disadvantage from people. Like, I knew students who in the middle of term, while classes were running, had to move to a different country, had to move interstate, and it's like really, really unfair to have them miss a week or two of the course while they're reorganizing their life, and then have them ranked against people who didn't have to do that. So that's why it was sort of blanketed last time, but this time it's like, yeah. Aquatia is saying, won't be surprised, you'll stay up for 24 hours, no sleep. I saw the memes. Students were saying, they were like, 24-hour exam shouldn't take longer than 3 or 4 hours, and then the student stays up for 24 hours and spends the whole 24 hours on the exam. I don't think the difference between, say, spending 4 or 5 hours and spending, say, 15 hours, the difference in marks between those two kinds of attempts is not going to be that much. It's not going to be enough for it to be worth it. I know people are going to do it. I know people are going to do it anyway, but I'm telling you, it's not worth it. But, you know, as I've always said, your education is your choice. So you want to fully commit, you want to go all in, then that is your choice, and I'm always going to respect your choice to do that. Except if your choice is to cheat, I'm not going to respect that. I'll respect your choice about getting educated, not about cheating. Yeah. Liang, people will take enhancers. You know, people popping, what is it, Benzodrine or something? Like in World War II, they used to have those pills. It was basically like a proto form of speed to try to stay awake. Look, don't risk your health on behalf of like a small number of marks. And also, I've seen people try to do this kind of thing, stay up all night and code, like just drink 18 cans of Monster and try to code, and you get worse. All right, I'm just warning you. The more stimulants you put in your system, the less holistically you think about things. So the more laser eye focused you get in on something, and that's where mistakes come out. So yeah, you'll get a lot of code written, but then you won't necessarily get to see it because we don't really release all the details about the exam, but you'll fail auto tests. You'll fail some of our auto marking that should have been obvious to you if you're awake. So just be careful about that kind of risk. Okay, so yeah, we're going to, as Tom's reminding me, let's take questions to the forum if you've got those questions, because we are supposed to be talking about the assignment at the moment. We will definitely be dedicating both a lecture and a live stream to the exam. So we'll have all of this later. So I don't think we necessarily need to talk about it right now. Oh, yeah, Leon, take it to the forum, because then we can answer you in detail, and because the question about the number of questions in the exam and stuff like that, we do want to answer that somewhere where lots of people are going to see it, as opposed to here in the stream right now. So let's get back to what I wanted to talk about in the stream. I've got a couple of things I want to talk about marking, because we've only got a few minutes left. We've got about 10-15 minutes remaining. Okay, so stage 1, we're expecting reasonably readable code. This has two things: the adding locations, we've talked about adding locations already today, and printing the realm. So when we boil this down to what you're actually doing here, you're inserting nodes into a linked list. So you're finding a position into a linked list, and then you're moving the pointers around so the stuff is inserted. Printing the realm involves traversing the linked list and then calling a function for each node in the list. So we have a set of functions. Chickens come to say hi. That do the actual printing, but you've got to call the right function at the right time. This is to test whether you can loop through the list. Note that these were some of the first things I did for the demo on the the Battle Royale as well. So we're considering these to be the basic things you need to know to be able to work with linked lists. So insertion means you know how to build a linked list in a sense, and then printing the realm means you know how to loop through a linked list, and we want those capabilities for us to say we can give you a passing mark for this if you can do those things. If you want to go further into a credit, we look at adding towers, and so that's inserting not just at that specific point at the end, but that's inserting at a specific at a different location based on name. So you'd have to check the name, see where it matches, and then insert. And also adding enemies involves creating new linked lists. So we're talking about creating new linked lists in memory and having a location have a pointer to these other linked lists in memory, so we can say this list of enemies is at this location. So you can see this immediately is a different level of complexity from the first stage to the second stage, because building a new linked list off one of the linked list nodes involves you tracking where you are in each of those lists. So a little bit of extra detail there. And then for this level of mark, so we could say 65 out of 100, this is the same as getting roughly 6.5 out of 10 in the testing, is to be able to have good testing for the first two stages. Whether it's good testing for the first two stages, or it's more testing of other stages, or it's really, really comprehensive testing for part of these stages, it's going to change based on your level of involvement in the testing, basically. And we're looking for a good attempt at readable code at this point. So when I say these are the average things that will get you to this level of marks. If you have very, very readable code here, then as you know, oops, where are we? As you know, 20% of code is code style and readability. So if you have performance at a credit level, but you have really, really good readable code, you might get pushed up to a distinction. So you may end up with 75 out of 100 because your code was so readable, even if you haven't got complete performance at that other level yet. So it's always like this idea of what marks you're going to get is a loose interpretation, but you can reasonably predict what marks you're going to get, knowing where you sit with the auto tests and how much effort you've put in to different parts of it, like code style. We had some really, really good code style in assignment 1. We had some people bringing their code to their tutors and getting quick style reviews and stuff like that, which was good. I think everyone now will have, having finished assignment 1 and gotten feedback from style, will have a decent idea about how you're going to get marked for style in the second assignment. So you're going to get marked for style nearly identically to the first assignment. So you know that any feedback that you got from the first assignment that said, if you'd done this differently, you may have gotten more marks, take that feedback on board, you can push this mark higher. So what we usually see is that people who are concentrating on writing good style will get, say, I would say 12 to 17-ish out of 20 in the first assignment, and they'll push that up to like 19 or 20 in the second assignment. Leon saying, does submitting empty starter code count for 20 out of 20 style? If you submit empty starter code, you don't get marked on the same on the same criteria. So basically everything that's below 50 gets marked on a different set of criteria. So unfortunately, submitting empty code won't get you 20 out of 100 for the assignment. I think if you submitted empty code with no attempt at solving any of the problems, I think we give you 1 out of 100 to say, here's your mark for learning how to type give 1511 castle defense. So you don't get the 20. But if you're below 50, and you had a shot at things and your logic seemed feasible, but you got caught out and your stuff doesn't compile and stuff, but it's styled really well, that will get you a higher mark. Whether that gets you over 50 or not is, I don't know. Every assignment's going to be different, right? We can't promise that an assignment that doesn't do anything but has really good style will pass, right? Oh, Dylan's asking, in the structures we're using, will there always be a null at the end of our linked list? Yes. That is something that we always kind of adhere to, and I apologize because here I did not put an arrow to null after the end of the layer, and I think it's just because I ran out of space, but there should definitely be an arrow. Let's just... there. Just going to edit this on the fly. Ooh, I've reflected that by accident. There you go. That should be better now. Yeah. That's a good question though, Dylan, because I implied that it wasn't in this slide. Okay, I'm going to leave that there in those slides, and thank you for pointing that out, because that's helpful. Okay, so the marks breakdown, yes. So stage 2 involves another linked list coming off the linked list that you've got there. Stage 3, now at this level, note that the marking is slightly different because we've got 5 stages now instead of 4 stages. If you're only looking at the early stages, the marking's the same, but if you get into the later stages, there's a slightly different way of marking. So I haven't said distinction, high distinction, credit, because the cutoffs are different for those. So a distinction starts at 75, whereas stage 3, where we're pitching at around 80. Oh, Leon saying, if you had a looped linked list, you wouldn't need a null. Yeah, if you had the pointer from layer pointing at castle, then you could have it as like a loop that kept going around. Yeah, and then you wouldn't need a null at the end. We use the null to say that this list has ended. If you have a looping list, you have other problems, though. So we haven't even taught you how to deal with the issues of how do you traverse a looping list and things like that, or how do you know where to insert and things. Dylan's asking, for these marks, are they including full style marks? They're not. So you can see how we're saying readable code, not necessarily perfect, but a good attempt. So what we're saying is this is the average. So if you can do these things and you're reasonably well styled, then you'll get a mark around there. If you have perfect style, this mark should get higher. So as I was saying, there's a chance, it's difficult, but there's a chance that completing stages 1 and 2 with perfect testing and perfect readable code takes you from a credit to a distinction. I'm not sure if there's a full 10 marks on offer there that could bump you up that high, but I think it's possible. Yeah. So it depends where you want to put your time and focus. If you find that solving the technical solutions is getting very, very difficult in the later stages, then you can say, all right, how can I shape the way that I'm building my code so that it gives us the best outcome in terms of readability? How do I separate my things into functions so that they're really nice to read? Can I think of ways to do my testing so that I make sure I'm passing all of the auto testing for things that are later as well? Yep. Okay, so stages 1 to 3, if you complete stage 3, that should get you up around the 80 out of 100. And this involves applying damage, which means what we need to do is loop through a linked list, look for certain conditions, because the only conditions that would have us applying damage is if there's a tower that has enemies at it. So you need to be able to check those 2 conditions, and then if those 2 conditions make sense, we need to apply the changes to the enemies, which may involve removing an arbitrary enemy from the list. So that can be an interesting thing to have to do, because you may have to do a removal partway through. And then if you're going to do that, you need to figure out who leaves that list and who stays. So there's a bit more work going on there. Also, advancing enemies involves, like, there's these groups of enemies that are in their own linked lists, and to move them between locations, how do we move the pointers around like that? It's just like that. You just move pointers around by slapping them. I'm not going to tell you how to do that, but there's going to have to be something to do with changing where the enemies are by manipulating linked lists and manipulating pointers to be able to move them between locations. So a little bit of fiddliness going on there. Yeah, pointer bending. See, I bent the pointers. Man, how cool would that be if that's what we were learning? Sadly, we are not learning digital element bending, although one could say we are. The 5th element in the future of the avatar world is bending of abstract data, which is what we do. We become data benders. That's really cool. Oh man, I gotta go ping CSE Review and tell them I've got a name for a show for them. I actually think they've already done Avatar as one of the themes of the shows. Anyway, I digress. Let's continue. Right. Testing as well, we want to see 3 stages tested. And if you're looking for a mark this high, 80 out of 100, we're wanting to see very, very good code style, right? So we're wanting to see you using functions to support your other functions. It's easy to understand. The variable names are looking good as well. So when we're getting up to this level, so this is like getting 16 out of 20 in style. 16 out of 20 in style is a very good mark for style. So that means that it's something that we could consider to be professionally usable. Could still improve, obviously, because there's still 4 marks out of 20 possible. But it's still, like, at this point, it's quite usable. So it's the kind of thing you could quite happily see in a business and say, all right, that's fine. We can work with this. 90 out of 100 is where we get up to stage 4. And here we're seeing this extra stuff going on with the searching. So note that the searching is like the icing on the cake here. So we're going out of linked list territory and we're going into strings here, and we're seeing, can you match strings using not just exact matches of the words, because if we want to do exact matches we can do string compare, but partial matches where some parts of the string works and we use kind of wildcards and that bracketing to match a series of possible letters against letters and things. You're going to have to look closer in the spec to look at that and use the reference solution to test the different ways that these strings do and don't match, and then try to figure out what your logic is going to be to do this matching. So it's not easy, but you want to get 90 out of 100 in an assignment, don't ask for it to be easy. So this searching allows you to find a series of towers in the list that match a series of criteria. And then we're using buffs to change the stats, either in towers or enemies. And when we're testing, obviously we're going to test everything. And we do also, especially once we're getting out to like 9 out of 10 of testing, want you to see if you can find some uncommon inputs and things that you don't, that you think someone might get wrong, you know? So there'll be some tests in the testing which are, you know, precisely the auto tests, and some which are like, okay, the auto test gives you a hint to something. What is the implication of that information we're giving you? Those are the kinds of things we'll be testing you for in the marking. 90 out of 100, when we're getting to this point, we're talking about code that's really easy to use. I don't know if you can hear that. A whole bunch of police just went past my house. At this point, we're looking at code that's very easy to understand, good use of functions that allow us to potentially reuse the same functions in multiple situations, which reduces the total amount of code we write, and all of the other things that we would expect with style. Yeah, the pointer police are coming because I've done too much data bending. Okay, full marks. Yeah, we're running too long. I'm 2 minutes over time. Yesterday was worse, though, I feel, because we actually, Tom, I don't know, you weren't there, but yesterday I did some of my best teaching in the question time after the lecture finished, because I had a really, really good error. So I don't usually slip up in a really nice way in a lecture, and I did an if statement that I did an if else without the else, so I just did an if, which meant if the if came true, both the if and the else ran. And the only thing the else was doing was allocating memory. So we had this memory leak, this ghost memory leak that we had to go back and find. I thought it was really, really cool. And I'm really sad that it was outside of lecture time and not in lecture time, because the bug didn't appear until like I think I was already overtime when the bug appeared. So it's a bit sad, but you know, hopefully some people will go back and watch that. Anyway, trying to get full marks for this. We're looking for all stages complete, beautiful code, comprehensive testing, right? You want full marks, you got to do everything. So we're looking, the add-on here is special effects on towers. So this is like the S level for what you can do with linked lists. We're saying some of the towers take certain enemies and send them in different directions. So some of the towers either send the enemies back, some of the towers hold the enemies in place depending on the different types of effects that are on the towers. And if the enemies move from one group to another group, the groups of enemies always have to stay in alphabetical order. Usually when we do our testing with you, we're just going to give them to you in alphabetical order, so you'll never have to do this. But if you have to move people from groups into other groups, you have to merge them alphabetically. Luckily, I've shown you it's not complete, but I've shown you a partial example of inserting alphabetic into the list, but not complete. So you have to make sure that works. Yeah. Joseph's saying, seeing me struggle and finding time. Yeah, and spending time is reassuring. Yeah, totally. So this is something that I say to people is like, high-end professional software developers still spend 15% of their time creating code and 85% of their time debugging code. We still spend more time debugging code no matter how good we get at it. The funny thing is, the things that we're asked to do become more complex as we get better at it, but the level of mistakes that we make as humans remains the same. The level of understanding of how the virtual world understands our communication doesn't necessarily get that much better. We still have to work quite hard to figure out what we've done when we make a mistake, and our mistakes are still human. So don't be too worried. It's never about trying to erase mistakes. It's about trying to detect them because they are inevitable, and then trying to figure out what's actually going on and fix them. There's more important a skill than to be able to create the code itself. Chapper Chap says, just wait until you're not using DCC. Yeah, I do enjoy how much people like DCC. I think that one of the potential issues with DCC is that it's not something that we would use in business because it's running a whole lot of stuff in the background for us to give us this information. But it would be quite possible to do all of your development with DCC, and then when you're going to deploy, after you know that it's safe, because DCC is safer than other compilers, then you do your final compilation before publishing something with a less safe compiler that has all of the speed optimizations in it. Maybe. I'm not sure. Yeah, so Tom's saying it's horrifically slow compared to something like GCC, and it also doesn't work everywhere either. So it's using a whole lot of extra stuff. And it's running your code multiple times to see whether it fails in different ways. So yeah, but I think it's really good for learning, even if it's not super efficient. And you can tell if you ever want to do a lab exercise using GCC instead of DCC and see if you still get full marks. Especially one with like memory things, or one with just using arrays and stuff, and like, because you can loop outside of an array with GCC, and it's kind of like, oh yeah, I think it's okay, and then when you run it, it crashes. So it would be interesting to do that if you wanted to. You are sacrificing marks, but you're sacrificing marks for learning, so maybe it's worth it. Okay. I don't have anything more that I want to say in terms of the assignment. This was my final slide. So I don't really need to say much about full marks, because it's the same thing that I said before. If someone can nearly read your code without knowing C, then you've done top tier style. That's hard to get to, so don't worry about it too much. Learn about progressing your style rather than aiming for top marks, I think. Leon's asking if Autotest uses DCC or GCC. It definitely uses DCC. We're not going to use an unsafe compiler to check things. And also, we get better information about what's going on in your program if we use DCC. So it's going to say what that student did was potentially risky, so we're going to flag it, as opposed to GCC, which says, oh, it's potentially risky, but there's also a chance it could be correct. I'm just going to compile it. Which is, it's a GCC thing. It's okay if you know so much about the code that you know the risks and you're willing to take them. but I actually prefer using something that's safer even when I do know the risks, and I know how to optimize things for it. Okay, so we've gone a bit over time, but I managed to get through everything that I wanted to talk about. Also, answering a lot of questions that people had today. So, if anyone has any more final questions now about the assignment or anything like that, feel free to put them in chat. If you have questions that you think are going to take a long time to answer or anything like that, please ask in the forums or go to a help session early next week, or utilize the lab, because you've got a full 2 hours of lab for every tutorial. Although we're allowing the tutorials to get a bit longer at the moment, but you've got a lot of time in the lab. So if you feel like you're not understanding things and you need help with your code, spend some time with your tutor, because they will be able to look at your code and talk you through how to solve problems that you're having. Hashtag GCC things. Dylan's asking, for our loop through linked list, does it go from the end node of the linked list to the starting node? I think it's going to go from the starting node to the end node. In terms of looping through this structure, we're always going to start here and follow the direction of the pointers until we get to this null, and we go, okay, that's the end. We're not going to loop from lair to castle. We're never going to loop opposite the direction of the pointers. The only thing that goes in the opposite direction to the pointers is the enemies. I was about to say why, but I'm not going to say why. I'm going to let you figure that out. When you implement it... Oh, if you implement advancing enemies, try to look at how you would implement advancing enemies towards the castle and then advancing enemies in the opposite direction, and see if you can guess why we're doing it in this direction. Yeah, so Dylan, we'll never be asked to loop from lair side to castle side. We will only loop from castle side to lair side. Leon saying, what if we want to play as the enemy? Well, Chicken, cover your ears, is very, very angry with you right now, Leon. This is her castle you're supposed to be protecting from those foxes. But even if you were playing from the enemy's side, you could still use the same data structure. You could still use the same data structure for moving your troops towards the enemy castle. I mean, like, when we think about these more modern castle defense games, they go both directions at once, right? Especially the multiplayer ones. All those idle games and stuff like that, where you just send your troops out. Yeah. So I don't think it particularly matters. I think we can have different perspectives on this and still use the same data structure, because we're the ones coding it. There's always going to be a way that we will be able to find a way to move our things around on this. Any other questions? I'll keep it open for other questions for a second, and if I don't see any other questions, we'll wrap it up there. Alright. Looks like we're done with questions. Chicken says goodbye. Good luck with the assignment, everyone. If you need help, remember, help sessions and labs, really good for one-on-one help. If you have theoretical questions, forum is really, really good for that. So look for the question. It may already have been answered on the forum. And if not, feel free to ask your questions on the forum, because you might be helping out a whole lot of other people. And it's really nice to help out other students with that as well. Okay. See you all on Tuesday for our next lecture. And thanks for dropping by on the non-regular time. See ya.